Hi, I'm Jessica and I'm a tutor here at Chegg.com. Today we're going to be talking about geometric proof. The first thing I'd like to go over is some of the basic terminology that you would see in almost every proof. So the first thing that you need to know are the reflexive, symmetric, and transitive properties. Reflexive property is when something equals itself. Generally, this is seen in a reflection transformation. Symmetric property is when A equals B and B equals A, so it's the reverse. This is generally seen in rotations. Transitive property says if A equals B and B equals C, then A must also equal C, which makes sense, right? Subtraction, multiplication, division, and addition are generally seen in algebra proofs, but they could come up in geometric proofs involving line segments or segment addition, angle addition, any of those addition properties, theorems, you would see that. Substitution is pretty common. It's one of the other ones that this is fairly things. So what we're going to do today is look at some geometric proofs involving triangle congruence. This is one of the hot topics involving geometric proofs. You could also see proofs involving transversals or similar triangles. Pretty much if there's a theorem in geometry, you can have a proof that goes along with it. So the first proof that we're going to look at is for side, side, side. This one's already worked for us to save some time. So if you notice, the given information is at the top of the page. This generally comes first in this type of a proof. Now, what type of proof is this? This is a two-column proof. The first column, you'll see statements, which is where all the algebra goes, or all the math. The reasons will be the words or the language over here. Okay. So these three are all given. So all these reasons are given. And because they're all marked, this is going to be side, side, side. And that means the triangles. Now, generally the last thing in the two-column proof in the statement side will be what you're asked to prove. Now, what I always tell my students is you never write the word proof in a proof, but they generally always will at some point. Okay, so in this one, we don't have anything written out for us, but there are some things marked, and therefore those will also be given. So the first thing that's marked on here will be angle L is congruent to angle N. And so what I'm going to do is erase what I've already written to save us some time. Okay. Now we know angle L is congruent to angle N, and it's given to us because it is drawn on the diagram. Anything drawn or written out is already given to us by whoever created the problem. Okay. The other thing that is given to us is the angles with the double marks. So that would be angle LOM and angle NMO. Okay, I got to match up, and I'm trying to think about it in my head. Okay, so LOM, and NMO. Okay, and that is given to us because it's also marked with a double line. Now, this is a pretty popular proof. This is created by rotation, and if you notice, MN is sharing the same line. Okay, so MN is congruent to NM. Now, the reason it doesn't say MN and MN is because M is not congruent to itself. It's congruent to O. Therefore, this is showing the symmetric property. Okay. Traditionally, on two-column proof, they give it to you where you have to fill in the blanks, and that's really what we're doing here. Now, we know that we're asked to prove that the two triangles congruent, and they are. Let me mark very quickly the congruent side. Okay, with one mark. And that will be angle side now. Okay, like I said, this is a pretty popular proof for triangle congruency, either side, 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 angle, side, or angle, side, angle, or HL. Okay, our bottom two proofs we're dealing with. So here we know angle A is congruent to angle E because it's marked, and it also tells us in the proof where it says given. In two-column proofs, 95% of the time, the reasons will come first. So notice A is congruent to E, and that is given to us. What else is given to us? Well, that would be AE bisects BD. Okay, that's written there. Generally, when you see a word in the statements column, diagonal to that word, you'll see the definition of that word. Okay, so if AC bisects BD, we're about to use that information. So AE bisects DB. Okay, that means it cuts it in half, so DC must be congruent to CB. That's going to be our next step in the statements because that's what bisects mean, cut in half. Okay. Now we've got, let me mark that. So DC is congruent to CB because AE is the bisector. Okay, well, what else? This says ACB is congruent to DCE. Well, that's this angle here. And I need two arcs because I already have it marked. What type of angles are those, you might ask? Well, those angles are vertical angles. This is also a very common occurrence in a geometric proof. Now, we know that the triangles are now congruent by angle, side, because we have two angles and a side marked. And the side is not included, so angle, angle, side. Now, if you ever see a part, like, for example, it'll say angle D is congruent to angle B after the triangles, that's when you're going to use the CPTCP formula. Congruent parts of congruent triangles are congruent. Okay, that's what would go there. Okay, number 6 here. We have PR is congruent to TR. It's already marked for us. It is therefore given to us. Now, we are also given that PQ is parallel to ST. I'm going to mark that on my diagram because it's not marked. Parallelism, we mark with a triangle. Okay, so these two sides are parallel. Now, you can bet that if the lines are parallel, you're about to use that information in some way. And we want to know about angle P and angle T. Well, we know that they're congruent. And if they're congruent and those are parallel, those are alternate interior angles from a transversal. And that's going to be our next reason, alternate interior. Now, generally, it might say alternate interior theorem or postulate. Usually, whether they call it a postulate or a theorem is based on the given textbook. And so, for our purposes today, I'm just going to say alternate interior because that's really what it is. But it might say theorem or postulate, whichever one it is in the book. Okay. The other thing we know is angle PRQ and TRS. Well, I need to mark those as well. This would be this angle here. And this angle, well, okay, those are vertical once again, so I'm going to erase that. So these are our vertical angles. Okay, now if you're looking at the triangle, I have angle, side, angle, angle, side, angle. Everything matches up. This is actually a rotation. Okay, it appears to be 180 degrees, but we're not really sure. Okay, based on the information that's parallel, it's all possible. Okay, so angle, side, angle would be our reason, and that's what there. So these two triangles are congruent by angle, side, angle. So this is your typical geometric proof. If you would like to know about other geometric proofs, you can always message me at this website, and I will be glad to help you out. Thank you.